For the next example, we're going to take a look at an application that involves concentration of an antibiotic in your bloodstream. So this one's kind of cool. You're given the function, and T, as far as our variables, T is time in hours, and then your Y variable, or C of T, is that concentration. So it's how much of that antibiotic remains in your bloodstream. For part A, what is the concentration 4 hours after taking the antibiotic? So all you want to do is plug in 4. So just be careful, like I said in the last problem, I recommend simplify the numerator, simplify the denominator, and then divide it out. So after 4 hours, you have approximately 4.88 milligrams per deciliter in your bloodstream. When you're asked to find the maximum or the minimum, you're looking at the graph. So you can graph it on your graphing calculator, and you definitely will have to tweak your window. You will, for this, if you're finding where it's the highest, you're finding a maximum. So in class next week, I'll show you how to do it on the graphing calculator. For this, we can look at the graph here. So I graphed mine on Desmos, and it does have that highest point, and so I can click right on that point. And so after 5 hours, the concentration is the highest in your bloodstream. So 5 hours after the injection. And it also asks, what is that maximum concentration? So that's the Y coordinate, and it's also, just by chance, happens to be 5 as well. Make sure that you include your units on these problems. And so if you think about the context of this graph, your x-axis is the number of hours. So when you first take the antibiotic, the concentration is increasing in your bloodstream. It reaches a maximum concentration, and then it decreases in your bloodstream over time. For part C, I don't think you have a part D on your notes, but I'll just do it for fun. But you do have part C. It says, in order for the antibiotic to be effective, 4 or more milligrams per deciliter must be present in the bloodstream. When do you have to take the antibiotic again? So how you would figure this out is under Y2, or on Desmos, you can just graph an additional equation. You would want to graph the horizontal line Y equals 4, and I'll show you that in a second. But here at after 2.5 hours, you have 4 milligrams of that antibiotic in your bloodstream. After that, it increases, and then after 10 hours, it starts to decrease below 4 milligrams. So you'd say that after 10 hours, that's when you'd have to take more of that antibiotic. Although part D isn't on your note sheet, it's good to talk about. So what happens to the concentration of the drug as time increases? So we did kind of already talk about this. Over time, that concentration reaches a maximum amount, but then it will decrease in your bloodstream. It will, if you think about what would the horizontal asymptote of this rational function be? So is the degree bigger on the top, bigger on the bottom, or are the degrees the same? If you said the degree is bigger on the bottom, you are correct. Whenever that degree is bigger on the bottom, your horizontal asymptote is that equation Y equals 0. So that means that this concentration is approaching 0 in your bloodstream. I'll show you on Desmos, just in case if you don't have your graphing calculator at home to find these pieces. You can use Desmos. Let me pull it up. So I just entered, here it is. I'll delete this one. That's the last problem. But if you look, you can always edit your window. So I'm going to do that. My x-axis is time. So maybe I want to know like over a span of a day. So 24 hours. And maybe I want to know more than that. Maybe I want to know like after 2 days what's happening. My y-axis, we know that that maximum value wasn't really that high. It was 5 milligrams. So you can see that's like a much, it's a good view of the problem. You can always adjust your window. So for example, if you want to know, instead of going by 1 on your y-axis, if you wanted to go by something different, you could. I don't know why that changed. So sometimes it's a little cranky. So when I look at this,